For plants to operate efficiently, the proper flow of fluids is essential. To keep liquids flowing through plant piping systems, pumps are used. All pumps have the same basic function, to move liquids through piping systems to where they're needed in the plant. However, different types of pumps are used in plants, and they're identified in different ways. One way that a pump can be identified is by the liquid that it pumps. For example, this pump supplies feed water to a boiler, so it can be called a feed water pump or a boiler feed pump. A pump can also be identified by its specific function in a process. For example, this pump creates a vacuum in a process, so it can be called a vacuum pump. Another way that a pump can be identified is by its physical location. For example, these pumps are located at the point where liquid enters a process, so they can be called inlet pumps. Now, there are also other methods that can be used to identify pumps. For instance, some companies identify pumps using letter and number combinations on process flow charts. It's also possible to use more than one name for the same pump. For instance, a feed pump that's located on the north side of a plant may be called a north feed pump. That name is actually based on two methods of identification, function and physical location. The thing to remember is to make sure that you're familiar with the methods your company uses to identify the pumps under your control. Pumps can vary greatly in several ways, but certain components are common to all pumps. For example, all pumps have an inlet, a casing, and an outlet. During operation, liquid enters the pump through the inlet, located here. This side of the pump is also called the suction side. The pressure of the liquid is lowest at this point. The purpose of the pump's casing is to contain the liquid inside the pump during operation. The casing houses all of the pump's internal parts. The liquid leaves the pump through the outlet. This side of the pump is also called the discharge side. The pressure of the liquid is highest at this point. Inside the pump, there's a component that physically moves the liquid through the pump. The type of component that's used determines the type of pump. Basically, pumps can be grouped into two general categories: positive displacement pumps and centrifugal pumps. A positive displacement pump uses a piston or some other device to push or positively displace controlled amounts of liquid through the pump. A centrifugal pump, on the other hand, uses an impeller which creates a centrifugal force to move the liquid. Centrifugal force is the force that develops when something moves or spins in a circular motion. In a centrifugal pump, this force pushes the liquid away from the center of rotation and out of the pump. On most pumps, a shaft is used to transfer power from a driver to the component in the pump that moves the liquid. The point at which this shaft enters the pump's casing must be sealed to keep the processed liquid inside the pump. The area between the shaft and the casing is commonly sealed using either packing or a mechanical seal. The simplest way to seal between the shaft and the casing is to use packing. Packing is a flexible material that fits into the space between the shaft and the casing. When packing is used, a small amount of process liquid is allowed to leak through. The leak-off acts as a cooling mechanism to remove heat from the packing. If too much leak-off is allowed, the efficiency of the pump may be affected. On the other hand, if too little leak-off is allowed, the packing will overheat, dry out, and possibly burn. The packing on a pump is held in place by a packing gland. The packing gland is bolted to the pump's casing, and it can be adjusted to maintain the proper amount of leak-off. Another way to seal between a pump shaft and its casing is to use a mechanical seal. Mechanical seals do the same basic job as packing, but they provide a more complete seal. A mechanical seal has two elements: a stationary element and a rotating element. Each element has a seal ring. The seal rings mate together to form a nearly perfect seal that has virtually no leak-off. To prevent the seal rings from drying out, overheating, and becoming damaged, some type of lubricant must be supplied to the seal rings. In some applications, the liquid being pumped is used as the lubricant. However, if the liquid being pumped contains abrasives or would be hazardous if the seal failed, An external source of clean liquid may be used to lubricate the seal rings. All types of pumps have auxiliary equipment associated with them. These pieces of equipment have specific functions that are necessary for proper pump operation. We'll look at 4 common types of auxiliary equipment: drivers, couplings, strainers, and lubricating systems. The purpose of a driver is to supply the power needed to produce the pumping action. Electric motors are the most frequently used type of driver. In this example, an electric motor drives the impeller inside a centrifugal pump. This driver is a steam turbine. Steam turbines are often used in applications where a steam supply is readily available. Another piece of auxiliary equipment is a coupling. A coupling is a device that connects the driver's shaft to the pump shaft. Couplings can be divided into 2 categories: fixed couplings and variable couplings. When a fixed coupling is used, the speed of the pump is fixed by the speed of the driver. To change the speed of the pump, the speed of the driver has to be changed. On the other hand, when a variable coupling is used, the speed of the pump can be changed without changing the speed of the driver. A strainer is another type of auxiliary equipment that's often used with pumps. Strainers are used to trap and remove solids from the process liquid before they can enter the pump and cause damage. Another type of auxiliary equipment that many pumps rely on is a lubricating system. A lubricating system is used to lubricate a pump's bearings. Bearings are used to support and align the moving parts of a pump. If the bearings are not sufficiently lubricated, they will overheat and they could be damaged. Now, there are 2 general types of lubricating systems: passive feed systems and forced feed systems. Passive feed systems use delivery methods such as gravity to deliver lubricants to the bearings. This constant level oiler is one type of passive feed lubricating system. The oiler has a small reservoir of oil that drains by gravity into the bearing. Another passive feed system is used on bearings that use grease as a lubricant. Grease is supplied at periodic intervals through a grease fitting on the bearing's housing. Some pumps need a greater supply of lubricant to the bearings, so they use a forced feed system. For example, this system pumps oil through these lines to constantly supply oil to the bearings. The system also has devices that filter contaminants from the oil. In this topic, we looked at some of the ways that pumps can be identified, and we looked at some basic parts that are common to all types of pumps. We also identified some common auxiliary equipment that's necessary for proper pump operation.